Hello everyone and welcome back to our course. In this lecture, we're going to use another plotting library known as Seaborn to continue analyzing and visualizing our features. Alright, so I'm going to create a new code cell continuing on in our collab. I'm going to import the Seaborn library. It's very commonly used. And let's start by creating, with Seaborn, a heat map. For this heat map function, I'm going to grab my data set and pass in a core function. This will return for me the correlations of my data set. And in fact, I'll just quickly make a new code cell and actually show you what that is. Look at this. So we have all of the correlations of all of the columns with each other. For example, open to open, they have a one-to-one correlation because they're exactly the same. We're going to take this data frame and we're going to make it more understandable by turning it into a heat map, which is a visualization. All right, then I'll call pyplot.show because even though it's Seaborn, we're still putting it into a pyplot frame. So I can also call pyplot.figure and I can set the figure size, for example, to 20 by 20. Then I'm going to run this code cell and look at this. We get our heat map returned. Okay, this is quite huge. I'm going to make it a bit smaller. Let's do 10 by 10, just so the text can actually be readable. For the heat map, it's more important to read the text because the boxes are just one color. So I could even do 5 by 5, whatever works for you. All right, so this heat map is showing us the correlation of values. So again, we have every column versus every column. If the column has a one-to-one correlation with something, it will be colored beige. That's why we have this big square of beige, because open to open, high to high, those have a one-to-one correlation. But then we can see if there's ever orange, then we have a high correlation. Okay, none of these have a high correlation. If we have about this violet color, that is 0.3 correlation. So we can see that volume has a 0.3 correlation to open, high, low, close, and adjusted close, which makes sense. Then the smallest correlation would be negative correlation, which we can see we have a negative correlation between decrease and volume. So a heat map is one way that you can analyze the features of your data set. You can also actually put all of the values right onto the heat map if you're interested as well, taking them from the data set and putting them straight onto that heat map. Seaborn has a lot more plots as well. For example, let's use Seaborn and let's make a pair plot. I'm going to pass in my data set. I'm going to pass in my diagonal kind. We'll do KDE. And a size, you can do 2. Then I'll run this code cell. And okay, kind. The diagonal kind will be KDE. And just let it run for a moment because it's going to create a pair plot, meaning it's now going to create the same as a correlation plot, comparing every feature against itself, but it's actually going to create for us a different plot for every correlation. So not just a different color, but actually a different plot. So it will take a couple minutes to run because it's quite a lot to create. All right, here we go. It's done after a couple minutes. We have here every column versus itself. It's kind of hard to see because it's so huge, but we can compare open versus open, high versus open, then low versus open, close versus open, edge, close versus open, etc. So it's another quick way to visualize the correlations or how different features are in comparison to each other. Now, along the diagonal, we have a different plot than a scatter plot. You'll see we have a density plot. That's because the diagonal is always going to have a one-to-one correlation, because it'll always be open versus open, high versus high, low versus low, etc. The upper right and the lower left, those are scatter plots. Awesome. Okay, join me coming up in our next lecture. We're going to learn how we can visualize our data with another API known as Bokeh. So join me in our next lecture.